Ever wonder how you can watch a video from across the world instantly, as if it's right next door, or send a message that arrives in a second no matter how far away your friend is? That's the power of the internet, a technology that connects us all, every moment of every day. The internet isn't a cloud or magic, it's a massive physical network of computers, cables, and special machines working together behind the scenes. Imagine a global spiderweb connecting billions of devices from your phone to giant servers storing websites and videos, all linked by invisible threads. When you go online, you're plugging into this worldwide system, joining a network that never sleeps. There's no single boss or central control. It's a decentralized network made of countless smaller networks, all working together in harmony. This design makes the internet powerful and resilient. If one part fails, data finds another route, so information keeps flowing. It all happens at incredible speed thanks to science, engineering, and the hard work of people who keep it running. We'll break down how your photos, emails, and videos travel the world in seconds, hopping from device to device. You'll see how tiny pieces of data cross oceans and airwaves to reach your device, using cables under the sea and signals in the sky. By the end, you'll understand why the internet is one of humanity's greatest creations, changing how we live, learn, and connect. It connects us all, and it's all powered by science and human ingenuity. Let's get started. When you send a photo or email, it doesn't travel as one big chunk. Instead, your message is split up before it even leaves your device. Your computer breaks it into thousands of tiny packets, like digital postcards, each carrying a small piece of your data. This process happens in the blink of an eye, so you never even notice. Each packet carries a piece of your data and a label called a header, which includes the destination address and a sequence number. The header acts like an address label and a page number, making sure every packet knows where to go and how to fit back together. This system is fast and efficient. If a packet gets lost, only that piece is resent, not the whole file. That means your information can travel quickly, even if there are hiccups along the way. Imagine sending a book one page at a time. If a page goes missing, you just resend that page. It's a clever way to make sure nothing gets lost, and everything arrives in the right order. Every time you click send or load a web page, your device acts like a super-fast mailroom clerk, labeling and sending out packets. It sorts, organizes, and dispatches data at lightning speed, working tirelessly behind the scenes. These packets are the building blocks of everything you do online. From streaming videos to sending texts, every digital action depends on them. Without them, the internet wouldn't work. The entire web would come to a halt without these tiny couriers. It's a brilliant solution to moving massive amounts of information around the globe. Billions of packets travel every second, connecting people everywhere. So next time you send something online, remember, it's all thanks to these tiny digital envelopes. They make instant communication possible, no matter the distance. They're the unsung heroes of the internet, quietly making sure your messages, photos, and videos reach their destination. Every message, photo, and video relies on them. Without packets, our digital world would simply fall apart. That's the magic behind your screen. Tiny digital envelopes working together to keep us all connected. Once your computer sends out those packets, their wild journey begins. Unlike a convoy, each packet travels independently, taking different routes to the destination. One might cross an ocean cable, another might bounce off a satellite, and a third could pass through a server in another country. The internet constantly finds the fastest, least crowded path for each packet. If a route is blocked, packets simply find another way, making the system self-healing. Packets often arrive out of order, but their sequence numbers help the receiving computer reassemble them correctly, like a jigsaw puzzle. If a packet is missing, the receiver asks for just that one to be resent. This process happens in milliseconds, ensuring your data arrives complete and in order. It's a high-speed, global dance of data. Every email, video, or web page you use is rebuilt from these scattered packets. The internet's design keeps information flowing no matter what. That's how your messages travel the world in a blink. It's engineering at its best. How do packets know where to go? Every time you send a message, stream a video, or load a website, tiny packets of data set off on a journey across the globe. But how do they find their way through the vast, tangled web of the internet? Routers, powerful computers, act as the internet's traffic cops. They're stationed everywhere, from your home to massive data centers, quietly directing traffic 24/7. Each router reads a packet's address, and decides the best next step, forwarding it along its journey. It's like a relay race, with each router passing the baton to the next. Your home router connects your devices to the internet, but out there, industrial routers handle millions of packets every second, making split-second decisions to keep everything running smoothly. These routers form the backbone of the internet, guiding packets through dozens of hops worldwide. Each hop brings your data closer to its destination, no matter how far it has to travel. Routers constantly share information, updating their maps to avoid busy or broken paths. This teamwork helps prevent slowdowns and keeps your connection stable. If a cable is damaged, routers quickly reroute traffic, keeping the internet running smoothly. They're always on alert, ready to adapt to any problem. Every packet's journey is guided by these digital signposts, ensuring it takes the fastest and safest route available. From your living room to massive data centers, routers keep data flowing. They connect billions of devices, making our digital world possible. Without them, packets would be lost and the internet would grind to a halt. Imagine a world where nothing loads. Routers prevent that chaos. Routers are the unsung heroes, ensuring your data gets from point A to point B no matter the distance or obstacles in the way. They adapt, reroute, and keep the world connected. Their work is invisible, but absolutely essential to modern life. Every online action depends on their split-second decisions. Whether you're sending an email or watching a movie, routers make it possible. That's how the internet stays fast and reliable, thanks to the tireless work of these digital traffic cops. For all these devices to communicate, they need a common language: protocols. Protocols are the rules everyone agrees to follow, like the rules of a game. The most important is the Internet Protocol, or IP, which handles addressing. Every device gets a unique IP address. Routers use these addresses to send packets to the right place. The Transmission Control Protocol, or TCP, works with IP to ensure packets arrive safely and in order. TCP checks for errors and reassembles data at the destination. Together, TCP/IP forms the backbone of internet communication. Protocols make it possible for a phone in Korea to talk to a server in California. They bring order to the chaos, ensuring data flows smoothly across billions of devices. Without protocols, the internet would be a mess of computers speaking different languages. They're the grammar and rules that make the internet work. Every click, message, and video relies on them. Protocols are the internet's secret sauce. Let's look closer at TCP, the protocol that guarantees your data arrives safely. Before sending data, two computers perform a digital handshake to establish a connection. Only then does the data start flowing. As packets arrive, the receiver sends back tiny acknowledgements, "Got it," for each one. If an acknowledgement doesn't arrive, the sender resends just that packet. TCP also reassembles packets in the correct order, using their sequence numbers. When all packets are received and acknowledged, TCP closes the connection. This process ensures your files download perfectly, and your emails arrive intact. TCP is the internet's quality control expert. It's why you don't get scrambled photos or missing sentences. Every reliable download message or web page uses TCP. It's the behind-the-scenes guardian of your data. That's how the internet keeps your information safe. Beyond moving packets, we need protocols for what we actually do online, like browsing websites. DNS, the domain name system, is the internet's phone book. It translates easy-to-remember names like google.com into numerical IP addresses. When you type a web address, your computer asks a DNS server for the matching IP. Once it has the number, it can send packets to the right server. To request a web page, your browser uses HTTP, the language of the web. Your browser sends an HTTP request. The server responds with the files for the page. If you see HTTP//, the S means secure. Your data is encrypted for safety. DNS finds the right house. HTTP politely asks for what you need. These protocols make web browsing simple and secure. Every click and search relies on them. That's how you access the web every day. All this digital magic travels through real-world infrastructure: cables, switches, and towers. We connect to the internet in three main ways: wired, Wi-Fi, and mobile. Wired connections, like fiber optic cables, are the fastest and most stable, using light to send data across continents and oceans. These cables form the backbone of the global internet. Wi-Fi frees us from cables, using radio waves to connect devices in homes and public spaces. Your device and router exchange data wirelessly, though walls and distance can affect speed. Mobile internet connects your phone to cell towers which link to the wired backbone. Data travels as radio waves to the nearest tower, then joins the global network. Each new generation of mobile tech brings faster speeds and more capacity. Whether by wire, Wi-Fi, or cell signal, it's all the same internet. The physical network makes digital communication possible. Every message, video, and call depends on these connections. That's how the world stays online. The internet isn't magic, it's a masterpiece of science and engineering. Every message, photo, or video is split into packets, each taking its own journey across a global network. Routers guide them, protocols keep everything in order, and physical cables and towers carry them at lightning speed. We've seen how TCP, IP, DNS, and HTTP work together to make the internet seamless. Fiber optic cables, cell towers, and Wi-Fi routers form the backbone of our connected world. Every time you go online, you tap into this incredible system. It empowers us to share, learn, and connect like never before. Next time you send an email or watch a video, think of the journey your data takes. Thousands of packets, guided by routers and protocols, racing across the globe. It's a beautiful dance of technology, happening in the blink of an eye. The internet is one of humanity's greatest achievements. Science is everywhere. Let the experts at Home Tech Compare ensure that you're choosing the right internet for your household. Visit HomeTechCompare.com.